Hello, guys. Welcome to another episode of IB Electronics World. And today we are going to discuss digital electronics. It will be the session number 2 for Boolean Algebra and Logic Gates. And mainly we are going to focus on NAND Gate, how we can use it, and how we can use various logic gates by only using the NAND gate. I will explain further. So the NAND gate symbol is if you have two inputs, A and B, it looks like that. So you can simplify with a NAND gate and NOT gate by doing this, A and B. Then a NOT gate, which give us A multiplied by B and then all this inverted. NAND gate, it's most commonly used logic, and by connecting them together you can create the OR gate, NOT gate, and also the AND gate. You can create the AND gate by using only two NAND gates. Again, we have one NAND gate with two inputs, and by using another single NAND gate, which is the inverter, the NAND, we can have C equal to A, B. Very simple. And for NOT gate, A is equal to A NOT. And if you want to create an OR gate, you need to use three NAND gates. Again, A, B, two inputs, first NAND gate, the second NAND gates, and the output of these two NAND gates, they're going to feed into another NAND gate, which is going to give us the OR gate. Another very popular logic gate is the NOR gate. In the last episode we talked about the NOR gate, and now we're going to simplify the NOR gate. So actually it's one OR gate. You remember that it's, instead of using a vertical line, it's just an arrow. We have again two inputs, and we have an inverter. So at this point is A plus B, and the output C is equal to A plus B that inverted. For the OR gate, you need to use 1, 2, and 3 or NOR gates. This one is going to fit here, and then you will have two inputs, A and B, and this one is going to feed to the A. And the result of these two are going to feed into another NOR gate, which is going to give us the OR gate. For NOT gate, similar to NAND gate, but you're using just a NOT gate, which is again, you feed A, you have a NOT. So you feed just the A, and you have an output as a NOT. And finally, in order to generate the AND gate, you need 3 NOR gates again. Very simple. So A, 2 inputs, and B, which are going to feed into the last NOR gate, and it will give us a C, which is an AND gate. Continue to the XOR gate. XOR gate, I will remind you how it looks like. The symbol. So you have one line, one arrow, and second, it's exactly like an OR gate but with an extra arrow. And so it's equal actually to C equal A plus B, or you can write it as A naught B plus A B naught. And last but not least, you can use the NAND gates in order to illustrate the XOR gate. This one is slightly more complicated, but you can achieve it by using one. This is an input, this is B, and then it feeds to another two NAND gates. And the output of the first NAND gate goes to the other two as an input, and the output of these two go to the final NAND gate, and it gives us C equal to A naught A B in all these parentheses, which again it's exactly the same as this one, which is equal to this one. And this is how you can create the NOR gate. That was for this session. I hope you enjoyed. If you enjoyed, please subscribe and like this video, and I will see you in the next episode.